Currently, our application is using a DAO authentication provider in order to authenticate the user. A DAO authentication provider compares the provided password with the password we have on record for a particular user. When the password matches, we authenticate the user. In this lesson, we're going to build a custom authentication provider which is going to act a little bit differently than our DAO authentication provider. In order to begin creating this custom authentication provider, we need to create a new class within our com.o'reilly.security package. So I'm going to hit Control-N to open the new dialog, and then just type class, and then we're going to name this class Custom Authentication Provider. And this class must implement the Authentication Provider interface. So once I have that interface selected, I can just hit Finish. And now we see our new Custom Authentication Provider class. You'll notice that because we have implemented the Authentication Provider interface, we have two methods that we must provide implementations for. The first is the supports method. This accepts a parameter of type class, and this is going to be the authentication class that we will support for this authentication provider. So this can be something like a username and password authentication token. And we can just inspect the class to see that it is equal to our authentication argument that's passed in. Now, there are other types of implementations of the authentication type that could be passed in here. So for example, let's say something like an X509 certificate authentication object is not going to match our username and password authentication token. So Spring Security would then know not to invoke our authenticate method in order to authenticate the user. So now we're talking about the authenticate method, and that's exactly what it does. It has the logic that will authenticate our user. If the user fails authentication, we return an authentication exception, and that will break the authentication chain. However, if the authentication is successful, we return a new implementation of the authentication object that contains the authorities granted to the user. We're going to declare a username and password authentication token. Because we know that this authentication object being passed in is of type username and password authentication token because of our supports method. So we can perform this hard cast right to that type of authentication object, and we don't have to worry about any casting problems. Now, what we'll do is we're going to auto wire in a new field that is of type auto user repository, and we'll just name that repo. We're going to use this to obtain the auto user from our database. So we're going to use the repo to reach in and find the username that corresponds with our auto user. So we pass in the username to the find by username method, and that returns us our auto user. At this point, we can then begin to inspect those credentials that we pulled from our data store with those that have been provided by our user. So we're going to use an if statement, and we're going to say if user.getPassword equals ignore case. So here's that case insensitive piece we spoke about. And we're going to check that it's equal to the credentials provided on the token that the user's logging in with. And we're going to send that to a string, and we're actually going to negate this. We're going to do a case insensitive comparison of the provided password with the password we have stored. If there is a mismatch, we are going to throw a new bad credentials exception, and we're just going to say the credentials are invalid. And this will break our authentication process and alert the user there's a problem. So what if we get past this check and we are successful? Well, at this point, we need to build that new authentication object. So we're going to once again work with the username and password authentication token. The first thing we provide is our principal or our user details object. And because the auto user implements that interface, we can simply pass it in. Next, we provide the credentials. So we're going to get the password here. And the next parameter that we provide is the authorities. So all those granted authorities to this user. So at this point, we have the implementation of our custom authentication provider. We just need to declare it as a bean, and we're going to give that bean a name of custom authentication provider, and this will get picked up via the component scanning. Now go back to our security context.xml file, and we're going to change the configuration of our authentication provider. The first thing we're going to do, remove the user detail service, and now we're going to use the ref attribute to specify the bean that is our custom authentication provider. So with our custom authentication provider in place, I'm going to restart our server, and then I'm going to navigate to the application, attempt to sign in as Junior Doe. First, I'm just going to provide the wrong password to test out that case. There we see we get some information saying that we supplied the wrong username and password. So let's go with Junior Doe once again, but I'm going to use the caps lock key here to enter password in all caps. And then when I log in, you'll see that we have authenticated. And under the old DAO authentication provider, which we were using, we would not have been able to do that. But because Spring Security grants us the ability to provide a custom authentication provider which can perform whatever logic we would like in order to authenticate our users, we can now have something like a case-insensitive check against our password. Not recommended, but it's just nice to see that flexibility.